Hello everybody, today I'm going to solve this problem, rotate list. Let's read the question first. Given the head of a linked list, rotate the list to a right by k places. Okay, so given a linked list, which has a linked list which has a node, every node has a value and then a pointer to the next node, and then some integer k, such that we have to rotate the elements. So for example, this linked list, for the first rotation, this 5 is broken from this 4 and comes to the front, so it becomes the head of the new linked list. The second rotation, this 4 comes to the front, and then it thus becomes the head of the new linked list, right? So every step we have to rotate it like that. So given an integer k, if we rotate this list k times, what is the resulting linked list, or the list is going to be? It's a single linked list, so we have to find that. So before trying to solve this problem, let's try to analyze the problem. Right, so we have given a linked list which is like this. So every time let's say k equals to 1, we break this from here and then migrate this linked list to here, and then this becomes the answer of that question, of the solution, right? So if k is equals to 2, we leave it intact and we break this, right? And then we again do the same thing. We point it here, and then this becomes the head of the new linked list, right? So let's see the constraints on that. The constraints is that, I mean, note that value, we don't really care about note that value, but k can start from 0, and then k can be 2 into 10 to the power 9, right? So this is the value of k. It doesn't say anything about the size of this linked list. It can be anything. So one easy observation that we can see is that after 5 rotations, it becomes the exactly same linked list that it was before when we do the 0 rotations, and then it just repeats. So we can easily, like, if the size, let's say s is the size of the linked list, right? So after s rotations, it just starts from 0. So we can, if the k is greater than size, we can easily reduce k equals to k modulo division size, right? So this way we can skip the redundant rotations, which will result in the same linked list, and then do the final rotation only, right? That's one optimization that we can do. Another optimization is, so if the size is 5, so for example in this array size is 5, right? And then if we are doing 1 rotation, then so from the initial head here we have to go 2, 3, 4 places, right? And that will be the tail of the linked list, and the next one will be the head of the linked list. If we are doing 2 rotations, then we have to go 1, 2, 3 places from the head, right? And this becomes the tail of the linked list, and then the next element becomes the head of the linked list. So clearly, like, we have to go s minus k nodes, and this node becomes the last element of that new linked list, and then the next element becomes the head of the linked list, right? If we can find that, I think our algorithm is really easy. So basically our algorithm is go s minus k nodes, right? New head equals to, let's say we are in the t node, which is s minus k times away from the head, right? So the new head will be t dot next And then again, since this is the new head, if case of 2, we have to again go up to the end, and then when the next is null, we have to point that to the head of that our previous linked list, and then we can simply return this 4 as a solution, right? So yeah, that's what our algorithm should do. So let's code it up. So what we are going to do is, first, the constant does not say anything about the value of head. It can be null, or it can be one length or 2 lengths, right? So we have to check all those base conditions as well. Null head, right? What if let's say we have a function called size equals to, right? Let's implement this function. It is not null, we've already checked that. So count equals to 0, and then we keep increasing head until it's null, right? And then finally we return count. So we have a function here. What if size is equals to 1, then no matter how many times we rotate the linked list, it's still going to be the same, right? If size equals to 1, then we can directly return head. Then we can decrease k by doing k modulo division size, right? What if k and size are equal? So if we have 5 elements and then we just rotated it 5 times, then it will be the exactly same linked list that we started with. So we can handle that situation also. K equals to 0, and we don't have to do any calculations. Now the next step is we have to go minus k nodes, right? So to make our calculation easier, let's start with a fake node. This is just some dummy node that we created, and we assign the next value to our head. Okay, and then we have a second pointer which we assign to the new head. Now let's say read equals to, so we have to go size minus k nodes forward, right? And that is our node. So since we are going from new head, it will be that the next node of this node will be the last node in our new array. Inverse is greater than 0. Okay, so since we are here and we started from new head, so the next element basically will be our new head, right? So we'll point our new head's next pointer to the temps next pointer, because this is going to be our new head. and then the temp will be the tail, right? So we have to point this to null, and then we still have to go to the end of the original linked list and assign the next value to the head of the previous linked list, right? So let's start with that. Temp equals to next, and equals to null, next, and all we have to do is equals to head. That's all we have to do, and then we can return, which is our solution. So this is basically how the solution can be achieved. Something is new head. Damn. What is going on, people? Whoa. So let's try to submit this, and hopefully there will be no issues. Yeah, so this is 100% faster than in solution. Hope you guys understood it. Thank you guys for watching. See you all. Bye.